So this is a cartoon about my disdain for the imperial system of measurement, which is what we use, versus the metric system. The U.S. tried to convert to the metric system. It was when Reagan was president, and I was in like kindergarten, and just the federal government tried to start like rolling it out, like, hey, we're gonna go to the metric system, and people were just like, no, and we just never did. So we still use this wacky system of measurement. But science uses the metric system for the most part, and it's much more useful. All right, let's move through this. Here's the next part of the cartoon. So miles are not metric, that's the joke. All right. Let's write this down. Units of a quantity describe what they measure, what the quantity measures or counts, and then unit analysis is just the process of working with units to help solve problems. That's what we're going to be focused on today, is unit analysis. So a lot of times in math classes, they'll focus on, right, the abstract math portion, and if a problem is like a word problem that has units, you're just expected to kind of tack the units onto the end of it once you get an answer, which is not how I want you to approach things. In unit analysis, we do the math with the units as well. All right, go ahead and give me a green check when you're finished with this slide, and I'll move forward. Okay, so what's the total distance traveled when you run 7 laps around a 400-meter track? So this is what I mean by we do the math with the units as well. All your numbers will have units attached to them. When you're multiplying and you have the same units in the numerator as denominator, those will cancel. So here, down here is what I want you to focus on. We have 7 laps. Thank you, Shayna. Okay, so this is what I was talking about when I said we do the math with the units. If we're running 7 laps around a 400-meter track, anytime we do math and we have numbers, we're going to attach units. So we're going to write 7 laps times 400 meters per 1 lap. Notice that we'll have laps in the numerator cancel with laps in the denominator, and we'll just be left in meters. So our answer will just be 7 times 400 meters, which is 2,800 meters. So your units should follow the same math as your numbers. Really, all you need to write down is what's at the bottom here. Go ahead and give me a green check when you're done, and we will move on. Again, you don't have to write the prompt down. You'll have that available. I'll also post the video of the lecture, but do practice writing down the actual work and the problem. Even a problem as simple as this, I would want on the free response portion of the quiz or the exam, I would want that work shown so I can tell that you're doing the unit analysis. Okay, so you want to, when doing unit analysis, we're going to be looking at a lot of word problems. You're going to want to be able to kind of break down the mathematics from the verbal description. So it's important to understand what operation they're trying to communicate. So the word per is division, so miles per hour. It's miles divided by hours. Of is usually multiplication. Sometimes I'll see a hyphen to represent multiplication in units. Square means raising to the second power or multiplying by itself. And then cube is raising to the third power or multiplying by itself 3 times. So feet times feet times feet is cubic feet or feet cubed. Again, go ahead and just give me a green check when you're good with this slide, and I'll know to move on. So next we have a conversion factor that is just a statement of equality that we can use to convert between units. So one example of that would be like 12 inches equals 1 foot. So I can divide either side so that I have 12 inches per 1 foot, which equals 1, or 1 foot per 12 inches, which also equals 1. And these things would be called conversion factors, right? And so here's an example. If I wanted to convert 9 feet into inches, I would take the 9 feet. I like to make everything a fraction, just so that it looks consistent to me. And then I would use that conversion factor. Now here, I want to convert to inches, so I would pay attention to, I want the feet to cancel in the denominator. So 1 foot per 12 inches. So I want inches in the numerator. Then we can see my feet cancel. Just multiply out 9 times 12. And we're just left with units of inches. So, whoops, I end up with 9 times 12 is 108, and my units work out the way I want them to, inches. It just makes it easier to look at. I don't like when I'm multiplying a fraction by a whole number. I don't know. I like multiplying just straight across, numerator to numerator, denominator to denominator. Listen, I can't get rid of fractions. Fractions are a necessary evil. And you're allowed to use calculators. All right, let's move on. So here's an example. Let's convert 94 days to seconds. I'm just going to blank it out so that you guys can kind of follow along with me. I want to convert 94 days into seconds. All right, so we start with 94. I'm going to put days. Let's put that over 1. Make it a fraction like Kai likes. And then we're going to multiply that. We want days to cancel, so we want days to be in the numerator. Or sorry, in the denominator. I want days down here. And 1 day, do you guys know how many seconds are in a day off the top of your head? No? Do you know how many minutes are in a day off the top of your head? No? Do you know how many hours? How many hours? Oh my God. 24 hours. Okay, so now if we multiplied this out, we'd be in hours, right? But we don't want to end in hours. So let's convert from hours. So we want hours in the denominator. 1 hour is, probably don't know seconds, right? 60 minutes. Good. Now hours cancels and we'd be in minutes. We don't want to be in minutes. In the end, we want seconds. So I'm going to multiply that by another conversion factor. And I want minutes down here. 1 minute is 60 seconds, right? And now I can see that minutes is going to cancel. The units I'll be left in is seconds, which is exactly what I want, right? So now you can just multiply straight across the numerator, multiply the denominator, and then divide. Now the denominator just ends up being 1 in this case, so we don't have to worry about that. But in any other case, you would also want to multiply out the denominator and divide by whatever that final number was. All right, so we get 8,121,600 seconds. In 94 days. All right, I'm going to jump straight to an example. And I'll actually write this out. We want to look at how many cubic yards of soil are needed to fill a planter that is 20 by 3 by 4 feet tall. All right, so it's 20 feet by 3 feet by 4 feet tall. And our question is, that's equal to how many cubic yards? Now, are you guys familiar with that notation that a little single tick mark means feet? And if you see it double notched, it's inches? Okay. All right, so right now we're in feet. You can do this one of two ways. You could find the volume first and then convert that volume to cubic yards, or you could convert each individual measure to yards, then multiply it out to find the cubic volume. I prefer the first way in this case. We're given feet. Let's find the volume in cubic feet, and then we'll convert our final answer to cubic yards, right? So the total volume, this is just a box planner, right? So it's just like that, where this side is 20 feet. We'll say this side is 4 feet and the height is 3 feet, right? So to find the volume of a box like that, you just multiply the dimensions together. So this is really just going to be 20 feet times 3 feet times 4 feet. And 20 times 3 times 4 is just 240. And I'm in units of cubic feet, because that's feet times feet times feet, right? And so that's going to be the most important when you do your conversion to yards. You need to recognize that you're in units of feet times feet times feet. Making it a fraction, putting it over 1. I want to convert to yards. How many feet in a yards? How many feet in a yards? How many feet in 1 yard? Okay, 3. So I have 3 feet in 1 yard. And I want feet in the denominator there, because I want that to cancel with feet in the numerator. Now, if I just multiply by this conversion factor once, what units am I left with? I can cancel out one of the feet. So this would actually be feet squared yards, which is a very nonsensical, right? Nonsensical unit of measurement. I want to end up in yards. So what I need to make sure I do is multiply by 2 more factors of that conversion factor. That way, now all my feet cancel with the numerator and denominator, and what units am I left with there? Yards times yards times yards, which is cubic yards, which is what I want, right? So again, you multiply out the numerator, you multiply out the denominator, and then you divide the two. So what I mean is this ends up being 240 over 3 times 3 times 3, which is 27 cubic yards, right? So 240 divided by 27, 8.89 cubic yards. All right. So the metric system was invented in France in the late 18th century for two primary reasons. One, to replace many customary units with just a few basic units, and two, to simplify conversions through a base 10 system, which is the system that we use for counting. So the basic units of length, mass, time, and volume are the following. You got the meter, that's your basic unit of length. Your kilogram, it's abbreviated kg for mass. The second for time, abbreviated with an S, and the liter for volume, abbreviated with a capital L. I would just make sure you write down these 4 basic metric units and their abbreviations and know those. It is weird that it's the kilogram, though, and not the gram. And we're just going to convert that into meters. So I'm going to make it a fraction. I'm going to multiply by a conversion factor where I have centimeters in the denominator, and I want meters in the numerator, right? So I just need to know how many centimeters are in a meter. So this will be 1 meter up here. Centi is 1/100th, meaning there are 100 centimeters per 1 meter. Centimeters cancels. We're left in units of meters, and we end up with 2759 over 100 meters. You can divide that out in your calculator. And that's 27.59 meters. All right. The marathon is 26.2 miles. How far is that in kilometers? So this you'll need another table for that I'll give you. It's not in here. But I will upload it for sure. So you would need to know the conversion rate that 1 mile is 1.6093 kilometers. And then I would take my 26.2 miles, I'm going to put that over 1. I'm going to multiply it by that conversion factor with miles in the denominator. So then all you're doing is multiplying the 26.2 by the 1.6093. We end up in units of kilometers, so 42.2 kilometers. All right. So temperature units, we use Fahrenheit, which, again, is fine with us because we're used to it and we kind of have it calibrated, but there's no sense making to the Fahrenheit scale. You know, it freezes at 32 and boils at 212. Who couldn't forget that? Makes total sense. Whereas the Celsius scale is calibrated such that water freezes at 0 and boils at 100. I'm just kidding. I was being sarcastic. Celsius is better, and it makes more sense for that to be the scale. But again, we've all just been indoctrinated to Fahrenheit, so I don't know. If you told me it was 30 degrees Celsius out, that could be super cold or super hot. I have no sense of reference for Celsius either. In science, we use Kelvin, which is the same as Celsius, except its 0 point corresponds to negative 273 degrees Celsius, which is called absolute zero, the coldest possible temperature, where even like subatomic particle motion would cease. It's never been achieved. So it's a theoretical temperature. We don't use the degree symbol on the Kelvin scale just to differentiate it from the other two. For Fahrenheit and Celsius, we do use the degree symbol, except you need to indicate with either a capital C or a capital F which unit of measure you're using. So there's your temperature units. Again, you can download these slides, they're available. And here's your conversion formulas. And so the human body is 98.6 degrees Fahrenheit. What temperature is it in Celsius and Kelvin? You could just use these conversion formulas to find that. So if I wanted to convert it to Celsius, I would plug in 98.6 for Fahrenheit, subtract 32 and divide by 1.8. That's going to get me 37 degrees Celsius. So there you go, 30-degree day in Celsius. That would be a pretty pleasant day, probably high 80s. And then if you wanted to convert to Kelvin, we would use this formula. Just add 273.15 to our Celsius temp, which gets me 310.15 Kelvin. All right, the last thing I'm going to do is let's do a currency conversion problem real quick. So these are some exchange rates. These are from way back in 2013. So they're probably not the same right now, but just for the sake of our numbers coming out the same, we'll use this table and use these conversion rates throughout the rest of this unit and on the exam. So you're given both rates, dollars per foreign or foreign per dollars. And so if a gas station in Canada sells gas for $1.34 Canadian per liter, what is the exchange rate in dollars per gallon? All right. So we'll do this at the top of the page. What we have is, let's do it like this. Whoops. $1.34, and that's Canadian dollars per 1 liter of gas. I want to convert this to American dollars per gallon. So first we're going to work on converting the Canadian dollars to American dollars. So I need to multiply by a conversion factor that has Canadian dollars in the denominator and American dollars in the numerator. So I'm going to go back to that table. This is dollars per foreign. So this would be American dollars per 1 Canadian dollar, right? So it's 1.005 American dollars per 1 Canadian dollar, which is the conversion that I want. And that way my Canadian dollars cancel. If I multiply this out right now, I would have my answer in dollars per liter, right? But I want it in dollars per gallon. So now I need to focus on converting liters to gallons. And so this is going to be in the table that I'll upload, but here's the conversion factor that we'll use. There's 3.785 liters per 1 gallon. So I'm going to multiply by 3.785 liters per 1 gallon. And that way I have liters in the numerator, I have liters down there in the denominator. Those cancel each other out. So now when I multiply this out, I'll end in dollars per gallon, which is what I want. So just multiply straight across. We end up with about $5.10 per 1 gallon. Okay. And that's it.